Hello viewers, welcome to Famous Julius Academy. In today's video, we shall be resolving some questions on Newton's laws of motion. In the last class, I gave some analysis of Newton's laws of motion, the three laws. I gave some formulas and some of the applications. But in today's video, we shall be resolving questions on Newton's laws of motion. Let's see the first question here. It says that a force of 10 Newton had for 20 seconds. What is the change in momentum of the body? This question you are seeing, we have, if you look at the parameters here, you notice we have force, which is 10 Newton. We have time, which is 20 seconds. And that should tell us that we are dealing with the second law of Newton, which says that the rate of change of momentum is directly proportional to the applied force. We say the rate of change of momentum, which is change of momentum is mv minus mv. The rate of change that is divided by time is directly proportional to the applied force. So remember, we know that F is equal to mv minus mv over t. This is our formula. So if we cross multiply from this force times time, we are going to have Ft, which is equal to mv minus mu. Now what is mv minus mu? mv minus mu symbolizes change in momentum. Change in momentum, which is change in p. And we say that Ft is equal to mv minus mu, which is also equal to impulse. It's also equal to impulse. So the product of force and time is equal to the change of momentum, which is also equal to impulse. And in lastly, we say that impulse can either be product of force and time or change in momentum. So if you look at this question, they say the force of 10 Newton. So we're given our force, F is 10 Newton, acts for 20 seconds. That's the time. Our time is 20 seconds. So what is the change in momentum? The change in momentum is change in p, which is the same thing as impulse. It can be equal to force times what? Time. So we have our force, we have our time, so we can multiply them together. So since the change in momentum, change in p is also equal to force times time. So our answer is going to be force is 10 Newton times time is 20. So if we multiply this, we are going to have 200. And what is the unit for this now? We are going to have it as force is Newton and time is seconds. So that is the answer, 200 Newton seconds. That is the change in momentum. So if that same question is asking you what is the impulse, that will still be the same answer. So because change in momentum is the same thing as impulse, it's the same thing as product of force and time of the body. So that is for the first one. And let's look at the second question. If you look at the second question, it says a body of mass 5 kg, we're giving mass that question, moving with a speed of 30 meters per second. Now, this is the body. Let's say this is the body. What is the mass of the body? The mass of the body is 5 kg. It was moving with a velocity of 30 meters per second. 30 meters per second. This is the direction of the body. So, what happened? The body of mass 5 kg moving with a velocity of 30 meters per second, speed, is suddenly hit by another body moving in the same direction. It was hit by another body. That means the other body is also, let's say this is the other body, is moving in the same direction. So he hits this body. So if he hit this body, that means he collide with the body. This is the body. Let's just draw it this way. This is the body. It's moving in the same direction with this body. And what will happen? Say it's suddenly hit by another body moving the same direction. This was hit by another body moving in the same direction. This direction. The same direction. Thereby changing the speed of the former body to 60 meters per second. Changing the speed of the former body to 60 meters per second. So the former body is this body. When this body hits this 5 kg body, it changes the speed from 30 to 60 meters per second. So let's say the body is here and is now moving with a different velocity, which is 60 meters per second. That means double of the initial velocity. And this is still our 5 kg body. So what has happened? This new body moving in the same direction with the body here hits it and it changes its velocity from 30 to what? 60 meter per second. That means it has already changed the momentum of the body. In the previous video, we talked about momentum is the product of mass and velocity of the body. So it has changed the momentum. Here the momentum was 5 times 30, which is equal to 150. Here the momentum is now 5 times 60, which is equal to 300. So it has changed the momentum of the body. So if you check, in fact, this is also an application of the first law, which is the law of inertia. A body that is at rest or in uniform state of motion will change its position or change its motion when an applied force is acted on it. Because this body was originally moving with 30 meters per second. It would have still been going with that 30 meters per second. But what happened? This body, which is the external force, had to move and change it. So that is it. And this is just like an application of the first law and the second law together. Here there is a change in momentum. Why is there a change in momentum? Because there was a force that was applied for this other body. So the force applied to this other body caused a change in momentum of this body. So now what did they ask us to look for? What is the impulse received by the first body? This is the first body, which is the body of 5 kg. They say, what is the impulse received? We see in the last question we solved that impulse can be product of force and time, can also be change in momentum. But have you noticed that this body has changed momentum from being 5 times 30 to 5 times 60? So the momentum has changed. So they're asking us for the impulse. We know that impulse is change of momentum. So we can say impulse I is equal to change in momentum, which is change in momentum, which is mv minus mu. So now, what's our mass here? Our mass is 5 kg. 5 times, what was the final velocity? This is our final velocity. This is our initial velocity. Our final velocity is 60 minus, what's our mass again? 5 times, what's our initial velocity, which is 30. So we now have 5 times 60, that will give us 300 minus 5 times 30, that's 150. So if you subtract 300 minus 150, you're going to have 150. So what is the unit of impulse? Newton seconds. Force is Newton, time is what? Seconds. So that is it. They asked us to calculate for the impulse. The impulse. So what is the impulse received by the first body, which is this body? This is 5 kg body. So the impulse is 150 Newton seconds. That is the impulse received by the body. So that's for the first and the second. Let's see for the third question. Let's see the third question. You have to clean this. Let's see the third question now. So the third question said a rocket expels gas at a rate of 0.4 kilogram per second. This will fall under rocket propulsion. In the last video I talked about this, the relationship between the thrust force and the velocity of the exhaust. And the relationship is given as the force, the thrust force, which is the force that makes the rocket to move forward, and which is the force that is the force responsible for ejecting fuel from the exhaust, is also equal to the product between the change in the mass over the time. This is the rate at which the mass is being consumed, is being expelled. So times the velocity of the exhaust. Now, this is a formula I gave in last class. This formula is very important. I think this is the formula we are going to use to solve this question. Here, look at this. A rocket expels gas at the rate of 0.4 kilogram per second. Kilogram per second. That is telling you about this quantity here. Change in mass. Mass is kilogram. Time is seconds. Kilogram per second. That is telling you this about this quantity. Change in mass by t. So we are already giving change in mass by t. Change in mass over t to be equal to 0.4, which is kilogram per seconds. We have given this. So let's continue. If the average force on the gas is 120 meters, the average force on the gas is the thrust force. F of t was given given to us as 120 Newton. So what are we looking for? They say calculate the velocity of the gas. Calculate the velocity of the gas. So we should regard as the velocity of the exhaust. So let's input our values into that formula and solve this question. So if we do that, we're given Ft as 120. Let's put it there. We're going to have 120 is equal to, they give us 3 m over T. Yes, it was given as 0.4 times the velocity of the exhaust, which we have to look for. So if we multiply these two, we are going to have 120 is equal to 0.4 V of exhaust. So if we want to look for V of exhaust, now we are going to have 0.4 divided by 0.4. So this can cancel this. So our velocity of exhaust will give us 120 divided by 0.4. So we can do some mathematics here. So we're going to have 120 divided by 0.4 is equal to 4. So if I turn this into multiplication, this will go up, this will come down. So we are going to have it as 120 times 10 over 4. So here, 2 here is 2, 2 here is 60, 2 here is 1, 2 times 60 is 30, right? So 30 times 10, that will give us 300. So the velocity of the exhaust is 300 per seconds. That is the velocity of the exhaust. And the last question there is a jet engine. In fact, the last question, I'll be giving the last question to solve. I think that is under rocket propulsion, just like this. So we'll use the same method to solve the last question. And when you are done with that, you can just put your answer in the comment section. So please, for more exciting videos,